Raghav, and the topic I chose for this science fair is Archimedes' principle. Why I chose this project is because when I was swimming in my pool and got out, I felt a lot heavier, and when I went back in, I felt a lot lighter, and I wanted to know why. And I realized this was all explained in Archimedes' principle, which states, when a body is immersed fully or partially in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced by it. And now I'm going to demonstrate Archimedes' principle. So I have a spring balance and a sandbag, and if I weigh it, it shows 2 Newton, which is equal to 200 grams. And if I weigh it in water, .8 Newton, which is equivalent to 80 grams. And now also the weight inside water decreased because of the upward force, the buoyant force. And to get the buoyant force, we need to subtract the apparent weight, which is the weight inside water, from the real weight, which is the weight outside water. And if we do this, we will get 120. And now we are going to measure the weight of the displaced water. So it shows 295. And it shows 182. And if we subtract the two, we will get 113, which is the weight of the displaced water, which is approximately 120. It is showing 113 and not 120 because the spring balance only shows an approximate value, not an accurate value. And also, some of the water is actually stuck to the jar, which results in a 7-gram error. And now, why did Archimedes come up with this principle? There is an interesting story behind it. Well, once upon a time, there was a fellow named Archimedes who was born in 289 BCE in Syracuse, Sicily. One time, the king of Syracuse asked his goldsmith to make a crown for him, and when it was done, the king suspected that the goldsmith has used a little bit of silver and the crown was not made of pure gold. But the king could not prove this, so he called in his most intelligent scientist, Archimedes, to help with this problem. But there was a catch. Archimedes could not damage the crown whatsoever because it was the king's crown after all. So, thinking about this, he went to take a bath in a fully filled tub. And when he climbed into the tub, some of the water was overflowing. And he also realized that the more he sunk into the tub, the more water was overflowing. After realizing this, he jumped out from his tub and ran out in the streets shouting, "Eureka, Eureka," which in Greek means "I have found it." And what did he find? He found the answer to the king's problem. Well, all Archimedes needed to do is, if he got a lump of pure gold and the crown and put them in 2 different jars, and all he needed to do is see how much water they displaced. If they displaced the same amount of water, then the goldsmith has not cheated the king. But if they displaced a different amount of water, then the goldsmith has actually cheated. But what if the goldsmith only used 10% silver? It will be too hard to notice the difference, even if the goldsmith has cheated. It will be too hard to notice the difference between the 2 displaced waters. And that's how Archimedes came up with a brilliant idea. But I don't have a gold crown and a lump of pure gold. But I have 2 objects that weigh the exact same. I have one rice bag and one sandbag. So they weigh the exact same. And when I put both of them in water, as you can see, since the sandbag has more density, it is sinking, while the rice bag is afloat. Similarly, the gold crown was afloat, while the lump of pure gold sank because it had due to the higher density, and thus proving that the goldsmith has actually cheated. And that's when and that's how Archimedes' principle was created. And now, when we talk about Archimedes' principle, it's all about buoyancy. And when we talk about buoyancy, the first thing that comes to our mind are ships and how do ships float. Well, ships were actually designed in such a way to displace a lot of water that is greater than the ship's weight. And a lot of the ship's underneath is actually hollow, which decreases the density of the ship. And a ship's bottom is actually curved. It has a curved bottom and not a straight one. It has a curved bottom to help it not tilt side to side, but instead go in a straight line. Thank you.